Okay, hello everybody. I'm going to walk through the following problems with you, and you're going to take some notes as I do them. I'm just going to show you really quickly what you should have in front of you. So your notes would look actually like this. You're going to fill in the slope, intercept, and point slope form. In your own words, you're going to describe the process that I used to solve this problem, my answers. In example 2, you're going to try this problem on your own. You're going to pause at this point so that you can try it and then check back in with the video. I'll remind you at that point. And then example 3, I'm going to walk you through another example, and you can compare my process to problems 1 and 2 and do a little explaining for me. So a little different sort of kind of notes section. So let's just dive in and see if we remember how to do this. So the whole reason for this one, why we actually need to use slope, intercept, or point slope form, is because we're going to be finding the entire equation of a tangent line. So one of our answers could look like this: y equals mx plus b. You know that old linear function where m is the slope and b is the y-intercept. With point slope form, it's a little different. We have y minus y1. We still have the same m for our slope, and then we have x minus x1. Okay, where one formula tells me the intercept in the slope, another formula actually just tells me the slope and a point. So here, my point that is also on my graph, I'll know my slope. I'll know that also a point x1, y1, whatever those two values are. I know they look a little bit backwards. Those two values that tells me a point on my line. So let's look down. This is what our answers are going to look like. Let's look down at the first example. Find the equation of the tangent line to this function at y equals 4. So right away I can see, I can start to imagine what this function is going to look like. For this function, it's a square root function. So if I think off to the side, what this is going to look like is just kind of gradually comes up and then flattens out. So definitely a non-linear function. That's why we can't use our regular slope formula. And x equals 4, let's estimate it's like right there in our line. We have to find out what the slope is, but not only what the slope is, what is the entire equation of that tangent line? So we're finding y equals mx plus b of this invisible line that is our tangent line that has the same slope at x equals 4. So the very first thing that we have to remember is that to find the tangent line, we can actually find its slope by using the derivative. So your first step is going to be to rewrite this equation so that you can take the derivative. And we're going to rewrite it, remember that this is a 1 on the inside and a 2 on the outside, as x to the 1/2 power. Our second step is going to be to use the power rule to find the derivative. So remember that with the power rule, we have to drop this exponent down and subtract 1 whole, which in this case is going to be 2 over 2. So we're going to have a 1/2 as our coefficient. We're going to leave the x, and we're going to get a negative 1/2. If we take the derivative of a coefficient, of a constant, we're going to get 0. So that's going to be plus 0. Now, the second step was taking the derivative. We're just going to clean this up real quick. What that means is we're going to leave our 1/2 out front. We're going to make sure that we put 1 over with an x in the bottom and a 1/2 as our exponent. And you're thinking, maybe why did I do that? Remember that since it's a negative, it needs to go on the bottom. Now there's going to be a little bit more cleaning up because we can see that we still have a 1/2 as our fraction. So we're going to leave that, we're going to leave that coefficient of 1/2 out front. But that fraction of 1/2, what we might remember at the beginning, what we did is we turned square root of x into a 1/2. Now we're going to take that 1/2 and turn it back into a square root of x. But what we have to remember is that now it goes on the bottom. Well, because it is on the bottom. This is our derivative. So the first 2 steps were just rewriting and finding the derivative. The third major move, the third step I would want you to write down, is that after we find the derivative, we plug in our x value that we want to find the slope of. So in this case, we're going to find the slope at 4 by plugging in 4 to that derivative where the x is. So this turns into 1/2 times 1/2, knowing the square root of 4 is 2, which gives us 1/4. Now, just remembering what this whole thing told us was that at the very beginning, what we were trying to find here was the slope using our derivative. So right here, this is our slope. So if we were to come off to the side and write one of our two equations, let's say y equals mx plus b, we now know that the m is going to be 1/4. We found that from our whole derivative process. Okay, now what we don't have is we don't have the b value to complete this equation. In order to find the b value, what we're actually going to do is actually find our x and y, plug those in, and work backwards to find our b. So off to the side here, we're going to go back, we're going to find a point, an x and a y value. Well, we already know one of our x values. Our first x value is going to be 4, and we actually know that that 4 is on both lines. So we can already plug it into our original function, and it should give us the same point. So we're going to use y equals square root of x plus 1, and we're just going to plug that 4 in the square root of x. Fast forwarding, we get 2 plus 1, which is 3. So we have the following point that we know exists on both lines, 4, 3. If you're using point slope form, that's x1, that's y1. But we're using y-intercept form, so we're still going to plug y as y and x as x, and we're just going to do some simple operations to find b. Now I'm going to write that as 4/1, because this is now just going to be some simple operations of 4 times 1 and 4 times 1, which is 4/4, which is just one whole. So I get 3 equals 1x. Sorry, that's incorrect. That's not 1x anymore. That's just 1. I get 3 equals 1 plus b. And if I subtract 1 from both sides, I get 2 equals b. Lastly, I'll just make sure to write my answer out and box it in, 1/4 x plus that b of 2. So I kind of stopped narrating my steps at one point. I was very clear about what happened when we found the slope in that 1/4, but our next step was to come off to the side over here and find a point on that graph as well. Once we found a point on that graph, our x and y value, our last step was to plug that x and y in and to solve for our b value. And that's the only way we can get that in y equals mx plus b form. I challenge you guys to go back up and use the point slope form right here and see if you can find what that equation would be in point slope form. Okay, the next step for all of us, we are going to move on to example 2, and I'm going to urge you to pause your video. Pause your video, solve this problem on your own. Before you solve it on your own, I should tell you that I want you to find at x equals 2. I left that part out. Solve this problem on your own. Come back and check your answer with me. Go ahead. Okay, welcome back. Here's all the work. So I'll just kind of go through this process and just kind of explain some things. And if you have any questions, feel free to ask them in office hours. But you can see that I'm going to start with my slope and actually finding my derivative. Here's my y prime right here. So I use the power rule for each one of these things. So check to make sure that you have the same y prime equation as me, and that you plugged in a 2, and that you found the same slope as me. You can see over here, I've kind of highlighted where that 7 came from, and you can see which equation I'm using. Now, this 2 and 4, these green 2 and 4, actually came from over here, where I actually found a point on my line by plugging in my original x value to my original function. Okay, and the way this function looks again is that this is parabolic, so it's a quadratic. So think about 2 being way off to the side, and we're trying to find its slope. Okay, and that's what's happening over here. We know that this point right here is 2, 4. We know its slope is 7. So this equation of this line, if we put it all together and work backwards, is going to have a y-intercept of -10. This is one equation that you can use Another equation that you can use is this one. This one is in point slope form. So check our formula from up above. See that this was just our y1 value and this was our x1 value, and I just plugged them into that formula. Hope that helps. I'm going to clear these drawings and move on to the last problem. The last problem is talking about something completely different, but it's extremely related to that last one. So this time, we're just going to read and annotate. The first thing that it asked me to do is find all x values. So I'm going to keep that in mind for this function that have a horizontal tangent line. What's vastly different about this one, we don't know what the x value is. I know that's not a typo. We're actually trying to find it. So you can't just plug in an x and work the same way we did in that last problem. We actually have to use the fact that it has a horizontal tangent line to find those. Well, what does that mean? A horizontal tangent line is going to be any line that becomes exactly flat for a moment. So think about something reaching a vertex and coming back down. That's a horizontal tangent line. What we know about horizontal lines is that their slope is always 0. So we know that whatever we have for this over here is going to have a slope of 0 in order for us to get our answer. So one thing that's really critical is that we use our formula to find our slope. What we do to find our slope is we use the power rule and the derivative. So remember that the 3 comes down. We're going to leave a 1/3 out front times 3. I'm going to make that 3 over 1. All x, if we subtract 1 now, to the second power. Remember that this 2 also comes down with that 2. So that's going to become a -4, x to the first. And that -5x becomes -5, x to the 0 power. And that the derivative of a constant is 0. Now we're just going to clean up. But our process is exactly the same to start, finding our derivative, because this has to do with slope. 3 over 3 is just going to become a 1. So just x squared. Remembering that there's an imaginary 1 out front as a coefficient. Minus 4x minus a regular 5. That x to the 0 is really a 1 whole, and if we multiply by 1 whole, we'll have the same answer. So this isn't our answer yet. We just have to use this now. So this was telling us that the slope of this line is given by this formula. Well, we actually know the slope is this. So if this gives us the slope, set our slope equal to that entire formula. So in this case, we're going to get 0 equals x squared minus 4x minus 5. And we actually can now solve to find our x values, which we're trying to find. We're working backwards. So how do I solve this? Well, this is a quadratic, so I should think about factoring it and seeing if it is factorable. Now 5 has factors of 5 and 1, and that's great because those factors will also subtract to give us 4. So I'm going to use a -5 and a +1, because using that combination, I'll get a -4 on the inside as my b term and a c term of -5. Now, we're almost done. All we have to now do is take these two things and set them equal to 0, because that's how we solve these equations, and we get x equals a +5 and x equals a -1. Those are our answers. We are done with that problem. One thing that I want you to consider is why we have two answers in this problem. This is a cubic function, and this particular cubic function is going to look something like this. Remember that this is what like x cubed, that parent function, looks like. Why does this have two answers? Well, if you remember, there's actually going to be two spots where it comes to a vertex, a maximum or minimum, and changes direction, where we would have a slope of 0. So right here, on that vertex, we'd have a slope of 0. And right here, on that vertex, we'd have a slope of 0. And we actually know where that is. One of them is going to be at x equals -1, and the other one's going to be at x equals a +5. If you want to go ahead and graph this on your own graphing software to see what this looks like, you're going to see vertexes there. So I hope this helps you. Explain that process. How is this one different? Think about the information we were given and the process that we needed to use to solve this one. I wish you the best of luck. I'll see you in office hours.